So our lesson 2.3, this is out of your textbook. It's lesson 2.3, solving for a variable. Your essential question, how do you rewrite formulas and literal equations? Okay, so with this lesson, basically we're rearranging mathematical formulas. And our definition of a literal equation are equations that contain two or more variables, two or more unknowns. There are many literal equations in the form of math, science, engineering. These formulas may seem like they can only be solved for a variable that is isolated on one side of the formula because they'll usually be presented a certain way. But by using inverse operations and properties of equality, the formula can be rearranged so any variable in the formula can be isolated. It is no different than how equations are solved by using inverse operations and properties of equality. All right, so if you look at this rectangular prism here, we have the length label, the width and the height, and the mathematical formula for the volume of that rectangular prism is E equals VH. Now, notice the B is capitalized and the V is capitalized, all right? Or V equals LWH. The capital V stands for the volume of the entire thing. And the B represents the base. Typically, capital V represents base, length times width, I think. V represents volume. Oh, it says it. L represents length, W represents width, H represents heights. Using inverse operations, the formula can be rearranged to solve for any one of the variables that might be unknown, like solving for X. A formula can be rearranged to isolate the variable. I feel like that V might represent something different. Because the capital V is volume. That's length times width times height. We'll come back to that. In the formula, V is equal to LWH, and the variable H needs to be isolated. Okay, the operation of blank is used in the formula. The inverse operation blank should be used to isolate. So in the formula, we're using multiplication. L, W, and H, those are all being multiplied together. And so I'm going to ask you guys to figure out what is the inverse operation of multiplication. What should we use to isolate H? Multiple choice question for you on your Pear Deck tab. You're going to pick one of those. I have 8 responses out of 22 so far. What is the inverse operation that we would use to isolate H? I'm trying to get H by itself. Okay, so I have 10 responses, about half of you guys, 11. Remember, don't be afraid to put the wrong response, okay? I just want to see how you guys are doing. So what do you think it is? What is the inverse operation of multiplication? And so overwhelmingly, we're saying division. Division is correct. Multiplication and division are inverse operations. They undo one another. Addition and subtraction are also inverse operations. They undo one another. Okay, so our correct answer here was, in fact, division. Okay, so the formula rearranged in this way can easily produce the height of the rectangular prism. So when the volume, length, and width are known. And so we have V equals LWH. So we're going to divide, because we said we're going to use division, divide both sides by the length and the width multiplied together in the denominator. We do the same thing on both sides. That keeps our equation in balance. All right, and so what does the right-hand side simplify to? When you have a fraction and you have common factors in the numerator and denominator, they divide out to 1, so they would eliminate. So if you see a pair of factors where there's 1 in the numerator and 1 in the denominator, they're going to disappear. They divide out to give us 1. So what's left over? LWH divided by LW. What is left over on the right-hand side? I have 9 of 23 responses. So it's multiple choice. All you got to do is pick one. So go to your Pear Deck tab and choose. Is it going to be L that's left over? Is it W that's left over? Or is it H that is left over? Basically, when I simplify the right-hand side of the equation, what is left? So I'm going to show our responses that we have so far. And most of you have said W. But in our problem, there's a W in the numerator and a W in the denominator. So W divided by W is 1. The W disappears, so it is not W. So you should change your answer if you pick W. It is not W. L divided by L is 1. W divided by W is 1. So all I'm left with is H. It's H. Okay. So using the formula for a rectangular prism, which is given here in pink, capital V stands for volume is equal to length times width times height. You're going to rewrite the formula to solve for L. What would that look like? We just did the formula where we solved for H. But now I'm asking you to solve for L. Good job, Jeffrey. And so when you are typing in your answer, you do want to attend to precision. So you want to keep the cases of your letters consistent. In this formula, V is capitalized, L is lowercase, W is lowercase, and H is lowercase. The L is actually even in cursive, but we can't be typing in cursive, I know that. So if we just stick with capitalization or lowercase to be consistent in your answer. You're solving for lowercase l, which you wouldn't have to type. You just put equals, or you could type lowercase l equals. You know, it won't be exactly the same. Good job, Harmony. Yes, you are going to use division, just like we did with the other problem. Because L, W, and H are being multiplied together, we are going to use division. So I have 6 of 24 responses. I need you guys to go to that Pear Deck tab and type something. I mean, if you only get L equals because you're lost, at least I know you're lost. But everybody should have L equals. Specifically, lowercase l equals. Okay, so there is some confusion. Let's look at the solution to this, okay? Because there were a few of you that got it, but this next slide, this shows everything worked out. So we started with V equals L times W times H. And then I'm trying to isolate lowercase l. That's the variable that I'm trying to get by itself. I'm trying to keep it on one side of the equation all alone. That's how you isolate a variable. And then because L is being multiplied with W and multiplied with H, the inverse operation of multiplying is dividing. So I'm going to divide by what will give me 1. So if I have WH there and I want to get rid of it, I have to divide by the same thing. I'm dividing by WH. With an equation, whatever you choose to do to one side of the equation, you must do to the other side. So that's why on the left-hand side, we are also dividing by W times H. And then we simplify it. Okay, W divided by W is 1, H divided by H is 1. They disappear, they cancel out, and you're left with just lowercase l. So L is equal to capital V divided by WH. So here's another interactive slide for you. How is the process of rearranging a literal equation? So what we just were working with, the one where I had you guys, the example we just went over, that's a literal equation. It has 2 or more variables. How is that process that we just did, we did together and then we did together again, how is it similar to solving an equation in one variable? Which is like an equation like 3x plus 1 equals 10, or 5y equals 20. How is the process similar? How is it the same? If you don't quite understand what to write, I would like you to just type that out so I know that the reason you're not typing something is because you're lost and not because you're doing our lesson on your phone and maybe you don't have the best connection. Okay, so if you don't know how to do this, you can also write that to me, but try to answer the question if you can. going to give you guys another minute to write something down here. Okay, we're going to go through some of the responses that we wrote. So someone wrote, it's similar steps, but not exactly solving an equation. Okay, I could buy that. It goes through the same process, just with letters instead of numbers. So they have different variables, but they go through the same process. That's a great answer. Okay, absolutely true. We're following the same rules that we have for solving an equation, which, like, the two main ones are do the same thing to both sides, right? Use inverse operations to isolate the variable you're trying to isolate. Because you could do the same thing to both sides, but you're not going to really achieve anything unless you're doing things that are going to help you get closer to your goal, which is to get the variable isolated. I don't know, that's honest. I have no clue. I don't know how to do this. Okay, it's okay if you don't quite understand right now because this is our first lesson. We're just getting into it, okay? They are similar because in both you have little to no information on the equation. Okay, it's similar because you still use a variable. Okay. Letters instead of numbers, yeah, that works. It's true. Okay. Literal equations have two or more variables. Okay, and our question that we're answering here is, how is the process of rearranging a literal equation similar to solving an equation in one variable? So how is it similar where you have two variables versus one? So those are good answers and honest answers of you don't understand, and that is okay that you don't understand just yet. So one thing we could say, in both cases, you use inverse operations to isolate the variable. Okay, that's a possible answer. You guys came up with some other answers that were really good. Okay, I liked it goes through the same process, just with letters instead of numbers. Okay, that's a good way to think about it. Okay. Well, this is a familiar formula, right? This is a literal equation, y equals mx plus b. You should recognize this from 8th grade. Solve for the indicated variable in each mathematical formula. Well, we're only going to do this one. So y equals mx plus b. Right now, the literal equation of y equals mx plus b is solved for y, because y is isolated on one side of the equal sign. But I want to rearrange it so that it is solved for x. Okay? So this is an interactive slide for you. It's multiple choice. What would the equation look like if instead it was solved for x and not y? As you're picking your answer from the multiple choice selection. First thing you'd have to do, because I'm trying to get x by itself, is I have to get this b out of here, right? It's plus b, and I want it to go away. So I need to use the inverse operation of addition. So in your choices, when I do the same thing to both sides, I'm going to have minus b minus b. I'm subtracting b from both sides. So make sure you choose an option that includes y minus b. We wouldn't add b. If I was to add b to both sides, I wouldn't eliminate the b on the right-hand side. I would end up with y plus b equals mx plus 2b. I'm getting further from the goal. The goal is to get x by itself. So choose an answer that includes y minus b. And then to isolate x, m and x, when two variables are next to each other like this, it means that they're being multiplied. So you need to use the inverse operation of multiplication to isolate x. What is the opposite of multiplying? In the given equation, we have addition and multiplication happening to the variable that we're trying to isolate. So in solving for that x, we're going to have to use both inverse operations. We're going to have to use subtraction and division. Most of you have the correct answer. 8 of you have this correct out of the 16 responses. Now 9 of you have it correct. Okay, x would equal y minus b, that quantity divided by m. Okay. I'm going to go ahead and show the steps that would be taken here. Okay, so if you're starting with y equals mx plus b, you would subtract b. When you subtract b on both sides, it gets eliminated on the right-hand side. And then when you divide both sides by m divided by m is 1, it's gone, and I'm just left with x. So this is a literal equation that we've rearranged so it's solved for x. Okay. Questioning strategy for you. This is your last interactive slide. How does the solution of a literal equation differ from the solution of a specific equation of the same form? So a literal equation, remember, has 2 or more variables. If it's a specific equation, let's say we have values substituted in for all but one of the variables. That's what that would mean. More specific equation is like one that you would be able to. So how does the solution of a literal equation differ from the solution of a specific equation of the same form? Like if it was y equals mx plus b. Well, the solution of a literal equation would have y equals mx plus b in it. A y and m and x and b. If it was a specific equation, maybe we know what the slope is, we know what m is, and we know what the y-intercept is. We know what the b is. So how would their solutions differ? How would they look different? How would they be different? Okay. I know a lot of you are a little bit confused. That's okay, you can be confused. I am going to stop presenting for a second, and I want you to come back to our Google Meet. Okay, so just tab back over to our Google Meet. And right now I have a piece of paper held up in front of my camera. So I'm looking at, for example, the literal equation y equals mx plus b. And I want to know, how does the solution differ depending on if it stays as a literal equation, like I have on this side. Okay, it's a literal equation here. This camera is like weird. So if it's solved for y, I really can't do anything except write that y equals mx plus b. But if it is a specific equation of the same form like I have right here, that means I know some of the values. I know that maybe x is 2 and b is 4. So then y equals, does it still look like mx plus b, or does it look like something else? Let's say I know what m is also. Let's give m a value as well. Say m is 5. Okay, so I could substitute all those values in to the point where it's 5 times 2 plus 4, 10 plus 4. So when it has specific values, I could get y is equal to a numerical value. Whereas the literal equation, it's in terms of other variables. And you come back to the Pear Deck presentation. Okay, this is the last slide of our lesson. So you can either come back to the Pear Deck presentation, or actually it is presented in our Google Meet right now as well. So how does the solution of a literal equation differ from the solution of a specific equation of the same form? Unlike a specific equation, the literal equation solution is not a number. It is an expression that involves the letters representing the coefficients and constants in the literal equation. Okay, so a specific equation, its solution is a number. A literal equation solution is an expression of variables, an expression of letters. Okay, so that's the end of this lesson.